Okay guys, today we are getting ready to start on lesson 3 of chapter 4, talking about functions. And today you're going to learn all that there is to know about functions. And functions is kind of a misleading word because we've not used that before. But a function is just a representation where every x, every domain is paired with exactly one range. Okay? So domain and range you talked about yesterday on Mr. Neugebauer's lesson 2. And so we know that domain is the x and that range is the y. So that means that for every x can each go to exactly one range. So now let's talk about independent and dependent variables. Well, again, this is just another way of talking about domain. So the independent variable is the domain. The dependent variable is the range. And again, if you remember, domain, independent, and x are all the same thing. Range, dependent, and y are all the same thing. They're just different words to mean the same thing. The independent variable, and I want to decide what that is. If I think someone's independent, if I'm independent, that would mean that I rely only on myself. I don't need anybody else. I don't have to rely on something else. I am independent. So the independent variable does not rely on any other value. Meaning it doesn't change just because something else changes. It changes all on its own. Therefore, the dependent variable is something is dependent, and that means that they rely on something else. Right now, you are a dependent of your parents. Your parents pay the bills, they buy your house, they provide you food, they provide you clothes. You are dependent on them taking care of you. So dependent variables has to rely on something else. So it changes based on how the x changes, because the y is not going to change unless the x changes. So if the x changes, then the y has to change. It's dependent on the x value. So now let's look at this table down here. It says we want to determine which one's the independent value and which one's the dependent value. Well, if I look at this first example, it says the equation C equals 0.99n. C is cost and n is music downloads. The thing that does not change is the number of downloads. The number of downloads, you can download 3, you can download 5, you can download 7. They're not all going to cost 99 cents. They're going to cost 99 cents each. So the thing that's going to change, depending on how many downloads you make, is the cost. It's going to go up if you download more. It's going to go down if you download less. So the cost is the dependent variable because it's what's going to change based on how many you download, and the independent variable is the number of downloads. So let's look at the second one. It says the equation D equals 4.5h is the number of miles D. So D is the number of miles. So let's write that down up here so we can keep this straight. So D is the number of miles that Amber can run in h hours. So what's going to change? Let's think about that. If I run for a longer time, and I know, me running, that alone is silly. But let's say that Amber, let's not even use me because that's never going to happen. Let's say that Amber is running. If Amber runs for 8 hours, is she going to run more miles or is she going to run less miles? Well, hopefully you know that she's going to run more miles because the longer she runs, the farther she's going to go. So what's not going to change is the number of hours. What does change, if I go up in hours, then I'm going to go up in miles. If I go down in hours, then I'm going to go down in miles. So this is the number of miles that's going to change. Does that make sense? Go ahead and try to fill in this next box by yourself. Pause the video, and when you come back, let's talk about what you got. Okay, hopefully you paused the video. I'm sure about 5% of you probably actually did. The rest of you are just waiting for me to tell you the answer. So I'm not going to tell you the answer. I'm going to wait until tomorrow so that you can actually do the problem. Yes, I know how you 8th graders think. Okay, So let's look over here. This is talking about how to write a function. Well, this is just saying that functions, the x is the independent variable. So the f of x just means that every time x changes, my y is going to change. Okay? So this is saying the function of x, let's say, is 15x. So now I can pick any value for x that I want and figure out what y should be. So let's say that I want x to be a -2. So what I'm saying is that when x is -2, I have to take that times 15 to find my y. So I plug in a -2 right here, because that's what it's telling me x is, which is a -30. So now I know that when x is -2, y should be a -30. Let's look at example 1. This says, find when x is -3, what this equation would equal. So I now know that x is -3 because it told me that my f of x when x is -3. So now I'm going to plug in -3 for this x. Okay, whatever's inside this parentheses is what you put in for x. So I'm going to put in a -3 here. When I put in a -3, I have 2 times -3 plus 1. And 2 times -3 is a -6, plus 1 is a -5. So when x is -3, my y is -5. Let's do A. This says when x is -2, and I put x in for this equation, what will y equal? Well, it's telling me that my x is 2. I may have said -2, and I apologize. When x is 2, what is my y? So I'm going to put my x is 2 minus 4, and 2 minus 4 is a -2. So when x is 2, my y is -2. Okay? All I did was replace this x with whatever value was inside the parentheses. Let's look down here. These are different ways that you can organize input and output. Again, input, domain, range, independent variable, they all mean the same thing. So let's write all that down. So I have input, domain, independent variable. Those are all names for my x. Okay? My y's then are my output, my range, and the dependent variable. Those are all names for my y. So on this, it says you can organize the input, the x, the rule, whatever the equation is, and the output, the y, into a function table. So here I have my x, here is whatever the function says, and then here is what my outputs are when I plug in these numbers for x. So in this first one, it says x is a -2. So in this equation, they replaced x with a -2. So a -2 plus 5 is a +3, so my range is 3. Make sense? So let's look at this next one. It says choose 4 values for x to complete this table. This is the table we're talking about. It doesn't tell me what 4 values to use. It just says choose 4 values. Anytime it tells you to choose 4 values, anytime you're told to choose values, we're all going to use the same 4. And the 4 that we're all going to use are going to be a -1, 0, 1, 2. Anytime you're asked to choose values, everyone is going to use those same 4 values. So everyone's going to use a -1, a 0, a 1, and 2. So let's go ahead and put those in. These are our x values. And again, everyone should be the same because we were asked to choose values. We're all going to choose the same values. And now I'm going to replace the x in this equation with these values. So my first value is a -1. So I'm going to put a -1 right in here for x. So I have a -1 minus 7. All I've done is taken this x and replaced it with this x value. So -1 minus 7 is a negative 8. Okay, now I'm going to put in a 0. So now I have 0 for x minus 7. 0 minus 7 is a negative 7. Now I'm going to put in a 1. 1 minus 7. 1 minus 7 is a negative 6. And then put in a 2. 2 minus 7 is a negative 5. Okay? And we should always have the same answers because anytime it asks us to choose values, we're going to use negative 1, 0, 1, and 2. All right, let's look down here at this problem. It says there are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of J, is a function of the number of jars. Well, what's not going to change is the number of jars. What is going to change is the number of peanuts because I'm going to take however many jars I buy. Let's say I buy 8 jars of peanut butter. I am then going to take that times 770 to see how many total peanuts were used. So my independent variable is the number of jars. Let's see. So the number of jars is the independent variable, and the number of peanuts is the dependent variable because I'm going to have to take that times however many jars I have. Okay? And it says, what values make sense for this? Well, can I use my negative 1? If I'm going to use my numbers, it's negative 1, 0, 1, and 2. Can I have negative 1 jars of peanut butter? No. So that's not going to make sense. I can have 0, I can have 1, and I can have 2. What about 1.5? Can I have 1? Can I go to the store and take my Tupperware container and buy 1 jar of peanut butter, but I only really needed half of another one, so I'm going to take my Tupperware container and scoop out half of the peanut butter and then put the rest back on the shelf for somebody else to buy? Of course not. So are fractions going to work in this? No. They have to be positive whole numbers. That's the only thing that's going to work because I can't have a negative jars of peanut butter and I can't buy a half a jar of peanut butter. So the only thing that's going to work is positive whole numbers. Let's try to find this out. Let's try to do one together. It says a scrapbook store is selling rubber stamps for $4.95 each. The total sales is a function of the number of rubber stamps sold. So it says identify the independent variables and the dependent variables. Well, the independent variable and the dependent variable, think of what's going to go up or down. Well, let's talk about the dependent variable first. What's going to go up or down? Well, hopefully you know that the cost is going to go up or down. If I buy more stamps, I'm going to pay more. If I buy less stamps, I'm going to pay less. So what's not going to change is the number of stamps sold. Someone may come in and buy all 500 stamps. Someone may not buy any that day. That does not depend on anything else to change. So what values make sense? Well, again, if I look at the 4 values that I'm always to use, which ones of those will not make sense? Again, can I buy -1 stamps? No. Can I buy 1.5 stamps? No. So if we're talking about things that you can buy, the only thing that's going to make sense is a positive whole number. Okay? And it says write a function, not a fraction, I apologize. Write a function to represent the total sales. Well, my f of n, because my n does not change, so my f of n equals, how much is it per stamp? Well, it's $4.95 per stamp. So now I can figure out how much someone spends on any amount of stamps that they buy. And it says, well, what happens if they buy 5 stamps? So what this is saying is that if I bought 5 stamps, f of 5, and I paid $4.95 per stamp, I can replace this in, because this is the number of stamps that I bought, with 5. So I have $4.95 times 5, because that's how many I'm buying, and $4.95 times 5, if you did that on your calculator, you would end up spending $24.75. So when I buy 5 stamps, I'm spending $24.75. Okay, if you guys have any questions, bring those in. Let us know what they are, and have a great night. Talk to you later. Bye.